Okay, perfect. Let's get started then. So thanks everyone. Today's topic will be on intro to programming, and we're going to talk deep dive into the anatomy of web apps. Because to make something interactive, that's basically the default thing that you will be able to make with a prototype using the AI coding tools we're about to show you. And that's the beauty about where we're at with this competition. It's never been so easy to just go from an idea and make a really impressive functional prototype. We want to show you later the simplest workflow that allows this to happen. And so you can make your idea a reality really easily. But it's really important to have some understanding of the technology that you will use. Obviously, none of us will go on to become software engineers, so we won't need to go to every minute detail. But it's really important to know just a bit about the structure of how your apps will work. And also, we'll talk about this using one of the lab projects as well as a real demo. So just a bit of background first so you guys have some context on the demo that I'll show. One of the lab projects we have is something called GP eval, which is basically building a better benchmark than what's currently out there. Because all the current benchmarks, they focus essentially on just multiple choice questions or some short answer questions, which is more about regurgitating knowledge than real understanding. Do you guys remember when this news first came out? It's 2 years ago now. It's nearly 3 years ago, February 2023. And ChatGPT was kind of all the hype back then. And it could almost pass the USMLE exam, which is widely regarded as one of the hardest exams in the whole world. And the fact that ChatGPT could pass it, it was just remarkable at the time. And only a few months later, it actually did pass the USMLE, which was, kind of the start of showing that these multi-choice benchmarks just aren't that capable of measuring how good large language models really are. Because if all the large language models can pass the USMLE with ease, that means that there's no differentiating factor essentially about what's better and what's not. So it's really important for us to create a benchmark that large language models actually struggle at. So this was literally just barely a month after the initial news that came out that ChatGPT can nearly pass. So it started actually passing. And then this was about 2.5 years later. Open Evidence, they created the first AI model that actually 100% completed the USMLE. So you can see that Open Evidence is essentially a large language model. So they an AI company that is specific for medical AI. I think they plug into the NEJM and they work with some of the leading journals to be able to grab evidence right from there. So, the ChatGPT 4 a few years ago already getting really close. ChatGPT 5 basically aced it, and they actually completely aced it. So it's more important than ever, essentially, to have a benchmark that can actually show improvements in these models because, if we develop a better model, we'll never know because it's already able to achieve full marks on the standard tests. So essentially, there's been talk for a while that there needs to be a better way to benchmark large language models, specifically in the medical context. So this was something published in the NEJM AI journal a while ago as an editorial, basically talking about the problems that our current benchmarks have. First, there's a lack of clinical realism because benchmarks, they essentially right now provide you a snapshot of the patient case vignette. And the large language model is really, really good at processing that amount of information and providing the most reasonable choice. So it's not able to essentially dynamically ask for information and account for the fact that diagnostics and management is an ever-changing process that always, that your management or your thought process always changes depending on new information that you get sent your way. So that's one of the key problems with these kind of snapshot multiple choice benchmarks. Another problem is data contamination and memorization, because the benchmarks that are used to test the large language models already exist in the wild. So it's very possible that the AI has already trained on this information. So when it does get a question right, it's really hard to differentiate whether it only gets, it knows option A because it actually understands the medical context, or because it's just seeing this kind of question like 100 times before in its training data and is simply able to regurgitate the information, which is something that we don't want when we're measuring how good large language models are. And finally, one of the biggest problems is that it creates an illusion of competence, because all the news articles that we see here about the AI model is able to 100% complete the USMLE, which everyone knows is a hard exam and is a licensing exam. So people may have the sense that these models are almost like basically as good or better than human doctors. But that's clearly not the case because of the lack of clinical realism. So essentially what our goal is to create a more realistic benchmark, because a large language model should be able to take a complete and comprehensive history. It should be able to know the relevant examinations to perform and also the relevant investigations to request. And this always will change depending on the information that the model gets. So we essentially want to simulate the dynamic process that clinical reasoning really is. So how we did that was essentially through a web app that is hosted somewhere that anyone can see. So how it works is that, so this is the full conversation essentially. And essentially this back and forth of the doctor which is a large language model that's being assessed, and also the patient, which is essentially another large language model that has a script and it just answers a question based on what the doctor says. So this is a history component. Essentially, you can see that there's a back and forth process that is quite realistic of simulating what a real doctor will ask. And if you guys just want to quickly glance through, it's quite reasonable, but clearly it's not very systematic as we have been taught. The doctor agent is also capable of asking for examination findings. So basically, it can make tool calls to ask for the exam findings that the patient has, and also the test results as necessary. So essentially the cases, they have test results that's relevant to the case, and if doctor asks the right questions, they'll be able to access this kind of information. And essentially, we are trying to hope that this is a more accurate way of simulating the diagnostic process, from taking a history to performing examinations to ordering the right tests, and essentially getting to the diagnosis. And we have an auto grade at the end that checks whether the diagnosis the doctor gave is actually the correct diagnosis. And the web app also includes a leaderboard, which essentially at the start, all the models, you can see ChatGPT 4.1, it could only reach about 70%. And most of the models were averaging about 50%. But you can see that the recently released ChatGPT 5 has already reached nearly 87%. And we'll run the Gemini 3.0 Pro as well that just came out, and maybe it will even surpass that. So getting close to saturation again. So maybe time for another benchmark that's even harder. We also do the analysis based on the performance and cost. So essentially, how much it costs per case, and it's only 6 cents, even at the most expensive end, for the accuracy that it's able to reach. So there's kind of a relationship between the more expensive, bigger the model is, the better it tends to perform. And also the effort. So how many words was the conversations in total? So we want, I guess, a model that is really efficient in that it doesn't ask that many questions, is really quick, but also gets really, really high results, which the ChatGPT 5 seems to be able to do really well. Okay, so with that in context, we're going to talk about how we've done this and how you guys can do this as well with the web apps. Does anyone have any questions so far about the benchmark? Okay, so to talk about what a web app is, we'll have a look at the anatomy first. So it's really important to think about any web page as essentially having a front end and a back end. The front end is what you see. So when you go to youtube.com, all the user interface, that's part of the front end. So it might be in the form of a web app or a mobile app as well, which is a bit harder programmatically for the prototype at least. So this is essentially the part that the user gets to interact with. But the back end is where all the data is hosted. For example, when you click onto a video on YouTube, what Google needs to do is that it needs to find the right video from its database and then send it back to you. So retrieve it from where they have it, so all the storage in the back end, and send it back to you to be displayed on the front end. So how all web pages work is essentially that there's essentially a part that the customer or the client interacts with, and then there's a part that only you can see that is the brains of the operation, essentially, that makes everything actually work. So, another analogy could be the vending machine that you see at the front is what the user interact with in terms of what menu that you want, what drinks or snacks that you want. You can have some way to pay. But what's really powering the vending machine and what's really the bulk of it is behind the scene where all the storage, all the logic for payment processing, where everything lies. So that's where the functionality essentially comes from. So to talk about the front end, what it's essentially made of is three kind of programming languages: HTML, JavaScript, and CSS, respectively. And I've actually whipped out a really quick demo to show you guys what the difference is for the three different languages. So essentially, the HTML provides a skeleton framework, the JavaScript makes it work, and the CSS is what gives the styling to make websites actually look good. So do you guys want to go on this link? So you'll go to a Google Drive link. It's either the tiny URL, so this is, you can type this, or you can scan the QR code as well to have a look at the demo. And you should see a HTML document here.
Yeah, we got it.
Perfect. Okay, so with HTML, you can see that essentially it's just code. So when you click into this, I want you to Control A to select everything and open a text document. So whatever the text editor is. On the MacBook, it's text edit. On the Windows, I think it could just be called text editor. And you want to copy the paste the whole thing in. And when you save it, you want to save it as a .html file. So I just named it as frontend demo.html. And once you save it as a .html file, you'll be able to open it on the browser. So once you copy the whole thing in and save it as .html, you will essentially get, and you can open it in your browser and it will look like this. When you guys get it open to this web page, I want you to have a look at the code. Essentially, this is a very simple mock-up of a shopping cart. You can order coffee and add to your cart. And on the right is a toggle to show code. So essentially, the first layer of the website is always HTML. This provides a structure. You can have a look at what the HTML code looks like. It looks scary, but try to break it down, maybe with the person next to you, to have a look at what you think, try to have an interpretation, essentially. And then have a look at what happens when you add CSS to it. CSS basically provides a style, and then JavaScript, it provides action. So you can see that this looks identical, but none of the buttons work right now. And when you add JavaScript, you're able to make the buttons work and essentially the web app come to life. It looks really complicated, but actually most of it should, essentially, you can get a gist of it from reading and try to see how much of information you get just from reading the three different types of code. So essentially, this is HTML only. This, I only put the CSS specifically, and only JavaScript is showing here. And if you guys want even more of a challenge, you can look at the proper HTML. So this is a full file that made this entire website possible. So feel free to have a look at that as well after you take a look at the three different snippets. So let's have a go at breaking this down. So with HTML, what it is that all it provides is a rough skeleton. So basically, it's a way to have the structure for you to build the rest of the site around. So you can see that what we got here is that we got heading 1 tag, essentially, which just tells us that this is big, bolded text. This P tag just means that it's a paragraph, so normal, unbolded, boring text. And this is, slightly bigger. This is a heading 3, so slightly less important than heading 1. And for example, the buttons as well, you guys should see is a code for that somewhere, where all it does is that, you just tag it as a button, and then you can type whatever text that the button has. But there's two problems with that right now. The first, the UI looks like it's from the maybe 2000s or even earlier than that, because the button, it clearly doesn't look very stylistic. Or everything is left aligned, it doesn't look very good. And if you were to see this websites, you probably wouldn't actually buy coffee from that because it just looks quite dodgy. But that's what HTML is. It gives you the framework to start working with. Now with CSS, essentially it's cascaded style sheets because essentially the most focus on is that the style is another language that gives you the option to make it look good. So you can see that straight away by adding the CSS, again, I haven't modified the HTML at all in this demo, but it just looks so much better. So with the HTML, with the code, we can break down to some components. This is a card. Essentially, just lets it know that we want the whole thing to look like a card. You can specify background, the border radius, the text align to be center. We can even have a shadow for this card. And we can make the button look really nice as well. You can change the color of the button, make the text change, the padding around, and also the radius. I think this is just to round the corners a bit more. But the problem with this is that as good as it looks, there's no functionality. So if you press any of these buttons, so I've coded to say that JavaScript is stable in this mode. So essentially without JavaScript, you're not able to make it work. It's just a button and that's all there is to it. And now when you add JavaScript, all of a sudden you can add things to it. So however many coffee on the order, and if you press add to cart, obviously there's no cart right now, but the button works and it's cool animation that supports it. So essentially it's able to get user input and the user can actually interact with it rather than just a static web page. So the code here is basically you have to tag it and let it know it's a script. Script is basically just a code snippet that adds a functionality. So initially the quantity is 1 and you have a function which basically allows you to, it's like a repeatable block that tells you to add the quantity of coffee that you want in the cart. And there's another function here which provides additional functionality as it suggests to add the item to your cart. So once the button is pressed, you're able to, it changes the text to added and it changes styles to green. So it's really cool and makes the website quite functional. And essentially this is the nervous system of the web page. It is able to get user input and change the website depending on what you're programming for it. But this is really, really complicated and has two main problems. So for example, the demo that I was showing earlier, the GP eval, that web page, it's got two different pages. So there's /leaderboard here, and this is /methodology on the other side. Now, these pages, even though they're quite different, they do share some functionality. For example, we want the menu bar at the top to be the same thing. Now, if you were to purely hard code a web page with the JavaScript, CSS, and HTML, every single page needs its own .html file like this. So you can see that this is obviously very hard to edit from. And if you want to add the same menu bar to everything, that means that you need to have a certain section of the code, for example, there, that repeatedly codes the menu bar. So you'll need to be basically copying and pasting some section here and some section there, which doesn't seem that big a problem until you have so many different subpages that you need to copy and recycle the same code for. And if you want to make any change, for example, if I want to add another button there, that means that I'll need to have to change the .html file across a lot of different web pages, which makes it really, really hard to maintain. So just for these two examples, we'll need to change the separate files and find that, and it's really finicky. So it's most important to know that's still how modern web pages are displayed. If you guys, I'm not sure if you guys played around with this in high school or something, but you can view page, you can actually inspect something. So you can see that this stuff, has anyone played around with this back in high school? I remember there were things that we would edit the report or something, like just for fun, because they display out grades to us in a web page, and then we can just change, go to inspect element, and then change the text to, for example, rather than morning roast, we can change it to 100% A+. And then it will display, it looks pretty legit. But what you guys are editing here is actually just the raw.html. So essentially, for the browser to display anything, it will display a .html file. So this is still really relevant in terms of what the front end consists of. But like I said, it's really, really hard and painful to code something like this. And no one does it anymore, which is why modern frameworks exist. So whenever you guys use the AI-powered tools in the future, it will basically just default to one of these. These are frameworks, and some of the really popular ones these days that you will hear of probably later will be React, Vue, Express, Ruby, and Flask. Just a special mention to Flask because it uses Python and it's really beginner friendly and simple. But the difference with frameworks and why that is taken over as a modern way to build websites is that it's really modular. So, for example, this is a section of the code that is responsible for the menu bar. We essentially have made our own little package that we can have different things on it. So, to go to /leaderboard, the button is leaderboard. To go to /methodology is methodology. Go to about is contact us, for example, like that. And with this, we're able to essentially just put only navbar on all our different web pages rather than having to hard code everything. And if I want to make any changes, for example, if I want to change leaderboard to scoreboard or something like that, I only need to change one place here, and then all of the different web pages will inherit this functionality. And it's almost like similar to the modern web builders or even Notion, which is drag and drop, but still using code. So this is a default that the coding apps you guys will be using will build on. So that's it for the front end. One of the problems is that even though I'm able to add things here, and I click add to cart, it seems like it's done something. Because this is only a HTML, or only a front end, this isn't going anywhere, right? Like if you click this, you're not actually adding $60 worth of coffee to your cart. So we actually need somewhere to store that information, and that's where the backend comes in. So this is a demo of what's happening when if you have a full website. So the front end, essentially, when you click a button, it will send a message to the server, which is where the website is hosted on. So if we play this again, you add to cart, it will send a message to the server. And the server will actually be able to track you as a user and know that you added morning roast to your items list. And this is really important because now we have someone to keep track of what you've added to your shopping list and what you have going on. So the importance of the backend is that this is where all the information is hosted. So it crucially handles all the logic. So this is things like the user authentication. For example, only you can modify your own cart, all the calculations like price calculation, time zone calculations, and also it can communicate with third parties. For example, most websites these days is powered by Stripe, so it will be able to communicate with Stripe and then to your bank to withdraw to actually debit the money. And for data management as well, it's really important because it needs to have databases to manage the user data and also the file and media storage. So for example, when you watch YouTube, that is where YouTube has essentially a database with all of your information and also where all the videos are stored. So it will retrieve that back to you to display the front end. So essentially, the separation is that you have the front end here. You will send a request to the internet and go to the server, and the server will know what to give back to you, which is why it's called a server. It's essentially, if you think about a restaurant, you order a food and the server just brings a dish to you. That's what the server does. It just displays the information that you request back to you. So another example of how emails work is that your browser is a client. It will send a request to the Gmail server that you want to see your emails. But it's really important that no one else can see your emails, obviously, unless you're logged in. So it first verifies your credentials. And then it will retrieve the emails from the database to be displayed back to you and served to you on your Gmail web app. So this is essentially the model that all modern websites work in. And let's talk about what a server is. So it can go as simple as a single board computer like this, Raspberry Pi. It's basically the default hobbyist computer, and this it looks really bare bones, but this is actually a fully fledged computer in its own right. There's no keyboard or screen, obviously, but this is where all the functionality is. So the chip for the processing, you can put a micro SD card there for storage, and you can connect it with USBs and also HDMI. But this is intended $50, and you can host your own thing. So the website I was demoing is actually entirely hosted on a Raspberry Pi. So tiny computer, and the drawback to this is that even though it's super cheap, for $50, I've got unlimited hosting anywhere rather than paying, say, $10 a month. But the problem is, if the internet in my house ever cuts out, then this will be down. So real websites have so many servers spread around the world, and even in different countries, they will have a lot of servers as is. So, let's say that one station has a power outage, there will be so many backups. And also another problem, you can imagine that if there's a power outage at my house or anything happened really, this will be down and the whole website will be gone. So as long as that doesn't happen, it should be on. So you can host, so a server can be something as simple as this. But it can also be a multi-million-dollar data center. So this picture is actually like a section of Wikipedia's data center. Can you imagine how much information Wikipedia hosts? So it needs to have somewhere there and needs to have a lot more compute because, for my website, maybe at most will be like 10 users at once. So it should be able to handle the data, handle that load. But imagine Wikipedia, they get probably millions of views every single second. So they need a lot more powerful compute to be able to know what to serve and serve the right things to the right people. So all these things actually cost a lot of money, not really for me, but for Wikipedia. So when you see something like this about, sorry to interrupt, Wikipedia, yeah, it costs a lot to run, even though it's completely free. So hopefully, see the Wikipedia, when they keep requesting for the donation, they really do need the money to keep up all their staff and also the very expensive computers. But also a quick tangent, a server can do so much. If you guys are interested in this kind of stuff, I highly recommend getting a Raspberry Pi because really the limit is only limited to imagination. So for example, my thing, even though hosting my website, is also working as a VPN. So right now I'm in Japan, for example, but I can still use my home network for anything because I have a Raspberry Pi there. You can also have things like network-wide ad blocking. So basically it filters out whenever there's a server that is serving ads, my Raspberry Pi can help me filter that out. So I'll never see any ad on my home network. You can do automations with N8N, which is really cool for building AI tools as well. And you can also host your own Netflix, basically. So essentially, if you download any show you want to watch, you can access it anywhere, just logging into Plex, which is basically Netflix that you can run yourself. So as long as you can download on your computer, that doesn't have any computer that you have, you're able to just log into this really cool interface and watch your media from anywhere. So it's really cool what a server can do, and it can range anything from as small as $50 to a huge data center. So in terms of the importance of the backend and why some people might wonder why we don't just have a front end that does everything. And that's because it will be ridiculously complicated in terms of how much information is being loaded. For example, my website is quite small in the grand scheme of things, but it's got 4,368 cases in total that you can retrieve and have a look at. And if I were to serve, all the cases to each user because I wouldn't know what they want, the website will be really impossibly slow and bloated and will send way more information than is ever necessary. So that's why it's really important to only serve what's necessary. And even in a more extreme example, imagine if YouTube tries to send its, however many terabytes of videos to every single user, that would be completely ridiculous. So essentially, how it connects is that the front end will make a request to the back end when the button is clicked. So on the website, to be able to display each individual case, you can select the AI model that you want to view and the case sets essentially. So in this example, we're selecting DispL. And when you click the view results, JavaScript allows us to, essentially it's JavaScript that's powering up the front end. and it will send a request to my backend, the Raspberry Pi. So it will essentially ask to get this based on this filter. So it will only retrieve what's necessary. So in this case, it will only want to retrieve the cases done by GPT-5 and only for shortness of breath presentation. And in terms of what this is API is the code. It's called Application Programming Interface. Essentially, application is a front end. Programming you can imagine as a back end. Interface is a way to allow to connect. So it's essentially how we connect the front end to the back end. So you might see it as an API request. So that's essentially what's happening. And when you click that, the backend will return some structured data based on what you're looking for. So for example, it will return all the cases that is relevant to our query, which is GPT-5 and dyspnea. So it will return, for example, the ID, the presentation, what the correct diagnosis is, the tags, and just other metadata. And obviously, if it returns like this is very unusable for the end user. So it's back on the front end to be able to recognize what we get back and display it in some really nice way. So obviously returning it this way is so much nicer than just seeing a bunch of code essentially. So for example, when you click the relevant view results, you'll be able to see the front end render that information into some really, I think, pretty and a lot more user-friendly format. So back to the restaurant analogy, the front end is basically the waiter. You tell them what you want to order, and the back end is the kitchen that's actually serving that for you. And the entire kitchen is basically the back end. That's where all the processing happens. And to combine the front end and the back end is something called stack. So traditionally, software engineering usually specialize either as a front end or back end engineer. So front end engineer will only work on the user experience, making the site really snappy, making the button layout and the design make sense. And the backend engineer will basically be dealing with database, authentication, and makes all the functionality work. But learning full stack, at least for the software engineering student, is basically the norm. So learning how everything works from the front all the way through to the database and the server is important. But still, people realistically still only specialize in one thing, but it's important to know everything. But for us, we can actually live in an age now where we can kind of be a full stack engineer using only Cursor or any of the AI-powered coding environments that you decide to use. So it will be able to whip up everything that like basically both sides of it and just make it work. So that's what a tech stack is. There will be popular tech stacks that you'll see. Incidentally, it doesn't really matter which one you use. The coding tool will make the decision. You can give it specifications if you want to be quite simple, like minimalistic, or retain all functionality. But that's how it works from the top to bottom. Just as a warning though, so the reason I say you're a full stack engineer only in brackets is because deployment is really, really difficult. Being able to spin up a prototype is super easy. You can just essentially just chat with the AI what you want, and it will make it mostly working. To deploy is really, really hard and probably requires some technical skill if you guys want to go that far, especially in medical AI projects where user data is absolute, the privacy is of paramount importance. So have you guys heard the T app? It's I think a while ago now, but essentially there's a developer with absolutely zero coding background. They didn't know how to code, so they just talk with Claude to code up their app, but they didn't know how to secure databases. So rather than there being authentication, all the user data was basically accessible from a link. And as you can imagine, it's absolutely catastrophic. So it's ironically an app that's designed for, I think, women to share information about men they've dated, but as a safety feature. So, but ironically, it actually leaked all of their photos and IDs, which is really, really bad. Only because the developer didn't know how to actually secure databases and deploy the app in real life. So you can imagine this absolutely catastrophic outcomes if you don't secure this right. And that's still a challenge, at least right now, with the vibe coding tools. So in terms of the final talks, hopefully you guys know a little bit about web development and how the process works from beginning to finish. There's really no limit to what you can do really quickly with prototypes. It's more about the idea. I think that's the limiting factor rather than the technical skills. Because for me to build that, it will require probably weeks to months of really intense work. But it literally could just be done in a couple of days using the tools properly, and you just focus essentially as the executive telling the AI what you want rather than being stuck in the weeds actually programming it. And it's really important for you guys, I guess, leading up to the presentation, leading up to the competition about how you can leverage your own clinical experiences. So, for example, the GP eval tool is that we know a lot more about how to benchmark and what realistic medical models need to do comparing to the software engineers that's designing the models. So how can you also use your unique clinical experiences to find the right solutions and come up with a really engaging solution?